Hi everyone, Jason here at the Whittier Public Library with our latest STEAM-powered science take-home science kit. This week we're celebrating National Library Week with not one, but two take-home science experiments. So we're going to go ahead and do two separate videos. This is going to be part one, and this one is called The Power of Books. Books are one of humanity's greatest inventions. They're an amazing way to store and share information, knowledge, and stories. They can make us laugh, they can make us cry, they can teach us, they can even inspire us to action. In fact, many different books have changed the world. But did you know that books are not just powerful because of their contents, they're also very strong objects in their own right. In fact, we're going to see how strong today. These two small books right here are stronger than you, and we're going to show you how. So let's go ahead and get started with our experiment. I recommend doing this with two small chapter book size books, about this size. This is Junie B. Jones and Magic Tree House. You can do it with larger books, but I wouldn't use anything smaller. In case you don't have a couple books this size available, we also gave you a couple packs of Post-it notes, which you can also use as a substitute. Those will work perfectly well. And don't worry, no books will be harmed in doing this experiment. Okay, let's go to a close-up and get started. Okay, so what we're going to do now is we're going to interleave our books. And that name comes from the fact that pages of books are also sometimes called leaves. And what we're going to do is we're going to put our books together so that we have one page of this book, one page of that book, one page of this book, one page of that book. You want quite a bit of overlap. I'll show you how to do this. Don't worry if you occasionally get 2 or 3 pages on one side or the other. That doesn't make sense. Just don't do big chunks. Couple pages is okay. And if you're using your Post-it notes to do this, you're just going to do exactly the same thing with your Post-it notes. Just make sure you have quite a bit of overlap. So I'll show you. You're going to start out the cover and the cover of the other book. And then you're going to do one page, 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 back and forth like this. Now, remember, it's okay to do a couple books. I'm going to go ahead and speed this up now so you can see the whole process, and we'll talk about it at the finish. Okay, so now we're finished. We have our 2 books stuck together. They should look like this. Notice they're a little bit thicker in the middle. And now we're going to go ahead and try something. What we're going to do is we're going to grab each of these 2 books, like right here near the spine. We're going to pull apart as hard as we can. Pull, pull, pull. If you interleave these properly, I'm pulling really hard. You should not be able to get them apart. Those books are stuck together now. But they're easy to get apart. When you're finished with the experiment, all you have to do is go like that, and the books will come apart. Okay, so why is friction holding these 2 books together so strongly that we can't pull them apart? Well, there's a few factors that go into this. Number 1 is surface area. So remember, how much surface is touching affects friction. And in this case, it doesn't look like much surface. It's just half the size of this book. But then you have to remember how many pages there are. Every one of those pages is touching 2 other pages. So that's increasing the surface area, multiplying it by how many pages. Second factor is the paper. So paperback books are usually printed on a little bit rougher paper. And a rougher surface is going to increase friction. So if you had a very smooth, slick paper book, that might not work quite as well. Third is going to be a couple of different forces that are being applied here. Remember, more force is going to create more friction. So first of all, as these books spread apart a little bit, you'll notice the spine is a little bit thinner than the books now. And the spine wants to pull these books, the pages of the books, back flat. So when you spread them out a little bit, the spine is pushing back down on those pages, applying a little bit of force. And then the main factor with the force is when you pull outward on these books, it actually compresses the pages and pulls them together, creating more force between the pages. And when they get squeezed together, that's more friction and they grip more strongly. And that's the reasons why friction is able to hold these books together even when you pull them really hard. We hope you enjoyed learning about the power of books. That's about it for our first experiment. We'll have a separate video for the second experiment. I also just wanted to invite you to please stop by the Whittier Public Library this week during National Library Week. We have lots of activities and take-home kits for kids. In fact, we have something going on pretty much every day. So make sure to come by and see us. We'll see you at the library soon. Thank you. Goodbye.